Question 7 is about continuity and differentiability. Here we have been given piecewise equation. You can see there are two pieces of equation. One is for less than 0 and one is greater than or equal to 0. They're asking us to find the differentiability for both the sides, the left hand and the right side derivative. Now basically you're finding the derivative and checking whether it's equal or no for both the sides. So how do we do this? Is very simple. If you're doing it manually, you have to just derive this, because I'm not going to use the formulas or anything. Why? Because this is first of all electronic part, and one more thing is derivatives can be easily found out by power rules, okay, rather than doing the formulas, long formulas, applying limits, which you have done earlier, and in the writing part, which is all detailed. These anyways very simple problems. Derive 2x plus 1, it's just 2. What is the derivative over here? It's 3. And we have to apply 0. It doesn't matter because there is no variable. So here the left side and the right side, they do not match. Are they equal? No, they do not match. They're not equal. So f derivative at 0 doesn't exist. Now if you look at the graph, they are at two different positions altogether, you know. So here it will be something like this, and there's a discontinuity, so it's not differentiable at that particular point. That is 0. That's the answer. But if you apply the formulas also, you'll get the same answers. F derivative or at 0 doesn't exist. Now I'll show you in the calculator. Here, since the x value is given, you can easily derive by pressing the shift and this integral symbol. You get derivatives. Type in the equation 2x plus 1. What is the x value? We have to derive it at 0, because we need to find at 0, isn't it? It's 2, and over here you just change this to 3x and it'll be 3. Similarly, you can try the other problems. It's all at 0, so I'll just change this to 0. The answer is 0 itself. Obviously, it's a constant. And then 2x will be, that is alpha and x. At 0 will be 2. So again, it doesn't exist. Why? They do not match. 0 is not equal to 2. This is wrong here. The limits do not agree. Why? Because it's 0 and 2 doesn't equal, so it does not exist. Whereas if it was the same numbers, then it exists. So let's see over here. I know for sure, because you will have x and x over here. The answer is 0 and 0 here. See, it will be x power 2, that is 2x after you derive. When you apply 0, it's going to be 0. And over here, x power 3 also is going to be the same thing. So it's again 0. So anything with x power 2, 3, when you derive, there will be a x term. And then this apply the 0, it's 0 itself. So yes, limits exist. Since the one-sided limits are the same, you know, left and right side are same. Even over you can do it by yourselves. Now I'll do the second one first. X squared plus 2x. That at 0 is 2. What about the above one? Yes, it's going to be the same thing, right? 2x is 2. So both the answers are correct. Both answers are not correct. It's same. That's the main thing. Since both the one-sided limits are same, we can tell it exists. And that's the end of question 7, which is a very simple and easy question.